So, is everybody there? Can you hear me? Can I hear you?
Yes.
You're awfully soft and far away. Hi, Brock. I see the Western contingent is up and awake. Why is he frozen?
I think that's just like a stock picture. There we go.
Okay, live picture. All righty. There he is, live. Who's that? Jordan. And where's Megan? Is that Megan? Hi. Okay, so who's here? Bob and Jordan and crew and me, Rima and Melanie at the library, and maybe a few latecomers. All right, we're going to start mainly talking about meteors. And as I recall, I asked some of you questions last time. So I have the questions, but I forgot who I asked. So who did I ask to define a meteor? Anybody? That's some people aren't here today. So
Oh yeah, I think that was.
who was that?
Was that Mary Lou and Jerry?
Mary Lou and Jerry, and they're not signed in. Anybody?
They're coming.
Oh, they're coming. Okay. Well, since they're a little bit late, does somebody want to answer what is a meteor? Otherwise, okay.
Okay, I'll answer.
All right, Bob.
A meteor is the thing you see streaking through the sky as this object from space comes through our atmosphere.
And what is the common nickname for that?
Shooting star.
A shooting star, Mary Lou. Yes. Hi.
Yes,
Was that your
sure.
question?
What?
Was that your question originally?
No, it wasn't.
Okay. Before I'm going to interject as we go through the answers with some additional information. Has anybody seen a bolide, and what is that? And if I call it a fireball, maybe you would.
Oh,
Has
no.
anybody seen a fireball?
no.
Okay, I saw one totally by chance. It was around 10 o'clock at night in October in 2017. That was what, 3.5 years ago. And I had just gone to bed and I just rolled over towards the window and this vroom, really bright shooting star went by. And I sat up and said, oh my, look at that. Wow. And then I couldn't quite believe it. So I was teaching, that was a Tuesday night, I think. So Thursday in my morning class, I looked at my half asleep students and I said, by the way, did anybody see a big shooting star Tuesday night? And one of the students says, yeah, I was driving back from Buffalo and this huge bright light shot across the sky. So then I came down to the library and they looked it up and it was quite famous. People from Toronto to the Carolinas saw it. And it seemed like it landed in the Atlantic Ocean somewhere, which of course is where most meteors land. We don't want to get ahead of ourselves. Who had the answer to meteorite?
Oh, Jerry did.
All
well,
right.
No, he got, no, that wasn't it.
Okay. Anybody
He's
want to answer
pretty
that?
good.
We have meteors falling out of the sky as shooting stars. What's a meteorite? Melanie?
Well, isn't it a sort of a stone that's got out of its orbit in someplace in the sky and then falls down?
Well, you're sort of on the right track. You're like one of my students that sort of halfway studied a half hour in the morning before the test,
Yeah, right.
but didn't do the real research.
Well,
Okay.
you corrected me when I said meteor when we were Googling the picture.
Mhm. A meteorite is what we call the meteor that has survived the journey and has
Okay.
landed clunk somewhere on the earth. Of course, I suppose there's still meteorites when they land in the ocean, but we don't usually retrieve those. So now the very fascinating thing I learned by my research, I would assume, wouldn't you, that a meteorite, when it hits the ground, is hot.
Mhm.
No, that's not true. And I said, really? The reason being, the last short part of its journey through the lower atmosphere, the atmosphere is so cold, 50 miles up, that yes, it was hot coming through, but it turns quite cool before it hits the Earth, which means, of course, the meteors that we see burn out, quote, up in the sky. They don't come usually roaring down, blazing to hit the ground. They're out by then. Okay, who had the question, the radiant and what that meant? Oh, and can we put the picture up?
Yep.
Of the radiant
I
since we're,
had- The radiant was my question.
okay, we're, whoever is looking at their computer for the Zoom talk, Melanie is putting up, well, we can do that in a minute. Can you do
Oh.
the radiant? I'm sorry, I switched them.
You switched them on.
Yeah. Well, I tell you what, let's leave
That's
this
okay.
up for a minute. Mary Lou, hang on to radiant. This is a sketch of our solar system. Can we make it a little bigger or
I
not?
cannot. Oh, wait.
Cannot?
No, I can't.
Okay, it's, sorry, guys, it's little. So what we see here is in the middle, the sun, well, it's off to the right, the sun, and going around the sun is the orbit of the Earth going this way. Yep. And then every once in a while, whizzing in from far, far away, sounds like a TV program, is this comet that comes and swings around the sun. Sometimes it's closer to the sun than the Earth, sometimes it's outside our orbit. And then it heads back out again to disappear, maybe for almost ever, maybe for 10 years, 70, what is it, 5 years for Halley's Comet? But in coming around, when it gets as close as Mars, the ice ball, basically a comet is a ball of ice and dust. The sun begins to evaporate or sublimate the water, the ice, and the comet then develops a tail, and this tail is a mixture of ice and water particles and grit and dust, debris. And after the comet's gone, that trail is left behind. And if you look carefully, somewhere that trail crossed our orbit. And that's what we call a meteor shower. When our Earth comes around its orbit and spends a few days, few nights running through that trail debris. Think of that movie, North by Northwest, when the hero is standing out in the middle of the cornfields waiting for the pickup. And the pickup truck comes from a side dirt road, leaving a trail of dust in the air. So that's what it's like. And we go through that trail of dust, and that becomes our meteor shower. And this, let me think. Let me look here at my notes. The ones that are coming up in August, the Perseids, we did not see the Perseids this week. It was a different one, but this one I had the information on. You might remember Swift-Tuttle, 2 astronomers. I think maybe one was actually an amateur. I'm not sure on that. There was a comet that came by in 1862, but this one, the Swift-Tuttle guys spotted in 1992. I remember that. I was living here then. And that particular comet left behind a trail of dust, which has become our Perseid meteor showers. Okay, let's go back to the radiant. Now we have Melanie found an image for us. Mary Lou, then you can tell us what is the definition of the radiant? Was that you?
Yes.
Okay.
The radiant is where the shooting stars seem to be coming from.
Yes. And so this is a schematic sketch, is that how you'd say it, of our very early morning, around 4:30 in the morning, night sky a week ago when they were at their peak. You know, they don't come and go in a day. Usually a meteor shower might last a total of 2 weeks, but they do have a peak date at which they're most numerous. So if we were up at 4:30 and if it had been cleared, it wasn't clear that night, and we looked towards the east at 4:30, it was still quite dark, no hint of the dawn yet. Vega, which is quite a bright star, one of the brightest in the summer sky, was rising, and there just above it, a little bit to the right, was the meteor shower we were looking for. And they all seem to be coming from a particular point in the sky, a particular constellation. And since it's Lyre, the constellation, of which Vega is the alpha star, we call it, well, I don't know Latin. So, but anyway, it's Lyrid, Lyrid. I don't know why, how they do that. All righty. Well, I sort of gave away the answer. Who had the source question? Maybe, okay, well, I already mentioned it.
Oh,
The most meteor showers come from leftover comet debris. However, once in a while, a biggie will come down. And that's usually because, and we'll talk about this some other time, the asteroid belt
yeah.
between Mars and Jupiter, it's a crowded, belt. And every now and again, some of the biggies clunk into each other, knock each other off course, get captured by gravity, and we wind up with a larger meteor. And maybe then, I don't know, someone could research. We're going to look, Melanie found a picture of the biggie, and when Brock tells us where it is, maybe that got knocked out of the asteroid belt rather than a tail of the comet. Okay, who had age? Was that somebody on the West Coast that I asked? Megan, did I ask you how old the meteorites are?
No, I had what is a meteorite? It's just the definition, and Brock had meteor, and then Drew has where is the largest meteorite?
Okay, well, we'll get to the where is the largest. So nobody had the age?
No, not that I know.
All righty. They're pretty much the same age as our solar system, about 4.5 billion years old. And that's one of the reasons why, and we have some more questions coming up for you guys on the West Coast about where we go to find these. If they land in the one of the trenches in the Pacific Ocean, we're not going to dive down 6 miles to try and find them on the floor of the trench. So the ones we find, we like to study because they have basically remained unchanged for 4.4 billion years and can tell scientists, chemists, geologists, astrophysicists, all those folks that have studied all those areas, something about the origin of our own solar system. That question the 2 or 3-year-old somewhere along the line will always ask, where did I come from, mommy? All right. And let's see, composition, Rima's running around doing library work, but she did the research on this. We're going to simplify it. What are they made of? Composition, 3 basic types with lots of variation. Yes. Jordan, think of your cakes. They're yellow cakes, they're chocolate cakes, they're white cakes. But then there's a lot of variation, right? You probably have hundreds of different varieties of chocolate cake. So we have metal ones, and most of the metal is iron and nickel, pretty heavy metals. And then we have the rocky ones, mostly silicate rocks, plus a little of this and a little of that. And then we have some that are mixed up. They don't know if they're one or the other, they're sort of both. And if you are Bob, you're listening, you're the chemist, if you want to later on go into greater detail, but I think we're going to leave it for the general public as those 3 simple categories. Okay, I think, Brock, this was your question. Where is the biggest? Was that a question you were going to look up?
Okay.
That was originally Jared's question, but Jared couldn't be here, so I was going to answer it for him. I'm Drew.
Okay. Oh, hi, Drew.
Hello. So the biggest meteorite was found in Namibia, Africa.
Okay.
It weighs about 66 tons, and it's about 9 feet by 9 feet, like length width-wise, and about 3 feet of depth. It's mostly made out of iron and a little bit of nickel. So it was the first category of meteorite you mentioned.
Okay.
Surprisingly, there was no crater where it landed.
Oh,
So they think it was a slow impact onto the Earth, and it landed about 80,000 years ago, they think. And the country, it is a national monument in Namibia, and its name is Hoba.
All right, we have a Melanie, the librarian here, found a picture of it, so we'll put a picture of it. They've made it into a bit of a monument. 80,000 years ago. Okay, that's when human beings had shortly left Africa to populate the rest of the world. And I think you have jived my memory. If it had come straight down, even if it was going fairly slowly, it would have probably made a crater. Probably what it did is come in at an angle. You might remember reading about the one in northeastern Siberia. I think it was 1910, give or take a few years. But that kind of came in at an angle, but it sort of blew up when it was like 100-200 feet or so above the ground there in the boreal forest. And it flattened the trees for like 20-30 miles around. Also did not leave much of a crater because it blew up before it landed as such. They should have a person there. So 3 feet high would be about to your waist, right? And 9 feet long by 9 feet is a super, super giant bed. king size bed. So pretty impressive. Now maybe I wonder if that was part of an asteroid collision rather than just a meteorite coming through the sky, dust from a comet. So that's what it looks like. And can everybody see this? I don't know if you're watching this on your computers, or if you don't, you can look it up. Okay, on size, the ones we see, the meteor showers, the normal ones, the size of the meteor is only the size of a grain of sand. A really bright one like the bolids would be more the size of a pea. So it's pretty amazing when you think a pea, could be that bright for 1, 2, 3, whatever seconds. But most of them that land, unlike this one, are the size of an apple seed. Okay, one of the West Coast kids had to find out where the expeditions go to collect meteorites, so the scientists can study them. Who had that, and where did they go?
Jerry did.
Oh,
And
Jerry
Jerry
did.
says you can go most anywhere.
Jerry, that's but where do they specifically go? Because it's easy to spot them.
Don't know.
Okay.
Mary Lou, it's Antarctica.
Yes, that's you, Bob.
Oh,
Bob, did you ever go to Antarctica?
I've always wanted to, but no. But a fellow I work with at the University of Canterbury did, and he went to find meteorites.
Can you tell us a little bit about what you would do if you were on that expedition? What time of year did you go, and how did you do it? Do you know?
No, they went. I didn't go.
Yeah,
But they took X-ray equipment with them so they could identify the substances present in the meteorites.
All right. I actually read a book by a guy who went on one 10 or so years ago. And of course, they go in their summertime. Let's not be too masochistic. And so that's our winter time. So in October, November, December, January, they'd be down there, and they use snowmobiles. And every morning, a group of them, maybe 10, it'd be like these things you see where the cops on the movie films where they're searching the lawn for the weapon, and they're lined up 5 feet apart or so, and they're walking along. Well, they're riding their snowmobiles about 10, 20 feet apart because they're out on the glacier or the snow fields. And it's pretty much white. And so the meteorites, which land clunk on top, and they're not hot, so they're cold. So they just lie there. And you can spot them. These little black or brown or dark blobs. Anywhere from, I'm sure the little ones are hard to find, but if it's the size of a tennis ball or a baseball or something on a white field, that's pretty easy for them to find.
yeah.
So they can collect hundreds of them every season.
Oh.
And I'm trying to remember, I don't remember, this guy might have been British, but I'm assuming they're international teams. And so each group, I don't know if they ever fight over them. Oh, I saw that one first. It's for my university and my country. I don't know. But anyway, it sounds like a fun way to spend your Arctic winter or summer. Alrighty. Jordan, did you research stars falling over Alabama?
Yeah, I did.
What'd you find? Anything?
Yeah, so it was a huge meteor shower that happened on November 13th, 1833. And there were more than 72,000 shooting stars per hour. And the astronomer Denison Olmsted, he was the one that coined the term radiant when he looked at it, and he really changed how people saw meteors, because before that, they used to believe that Aristotle had come up with that meteors were gas bubbles that ignited in the atmosphere. So they realized after this that meteors came from space.
A couple of things, so don't go away. I had to laugh. Gas bubbles exploding when they hit our atmosphere. You see, science is not about producing absolute truth and answers. Science is a series of questions. Why? Why does that do that? What is that? How could that happen? And the answers you find grow out of what you already know. And if you don't know a lot, then your answers are less likely to be true. Now, we all know gas explodes. We've all had experience with that, especially in older times when you didn't have electricity. You worked with gas stoves, kerosene stoves. We've all had accidents, and we know things blow up. And so when you saw these sudden bright flashes up in the sky, and I think in those days, the 1800s, we did know, I'm thinking we knew the composition of the atmosphere and that there was oxygen present in it. So that was a reasonable guess given what they knew at the time. But the only way you get from there to a more perfect truth, but not necessarily the whole truth, is to continue to observe and question and keep records and think about it and come up with new experiments to see if your guess is better than the last guess. So give me that date again, Jordan. In
Yeah,
the
that's
18,
a good date.
what was the date?
November 13th, 1833.
18th. Okay. I had a date for 1966. Now, why did I have that date? And that was 100 meteors per second in that particular shower. And maybe, Jordan, you could do some more research. Was the first one over Alabama, where the people got very excited and the religious people all went to church? They thought the world was ending? Or was that the one in 66? Hello?
Sorry, I
West
muted
Coast is-
myself. They thought the world was ending when it happened in 1833.
Okay. Well, maybe not right now, but if you have 10 minutes, to do some future research. See, I just take notes from my science astronomy magazines, and sometimes I don't get it all right. I had jotted down 66 stars over Alabama, which, by the way, they made it into a song.
Yeah.
So you can check out the song too. The Night That Stars Fell on Alabama, or something like that. Okay, let's finish up with meteors, or we're going to run out of time to talk about our questions for next time. What have I got on the backside? Oh, we have another picture of a famous meteorite. I keep having to stop to think which is a meteor and which is a meteorite. Meteor, they're still in the sky. A meteorite, they're on the ground. Think about it. Until very recently, almost everybody believed the gods lived up in the sky. And obviously, if a fiery ball plummeted out of the heavens, it probably was a message from one of the gods telling you something or other. And so if you're curious, you could do a search for famous meteorites around the world, often connected to religious sites. And you want to put up the Kaaba there, Melanie? One of the famous ones that I know about is the Black
What
Stone,
is it called?
the Kaaba. You had it up there, the first pictures you got when you,
Oh, I lost
okay,
it.
just,
K-
okay,
K.
Kaaba, K-A-B-A, I think. Or Mecca, the Black Stone. Maybe that would, she lost it, we're finding it. But for the Islamic world, the center of their religious faith is in the city of Mecca, in the Great Mosque, in the courtyard. Here we have a whole series of pictures. Let's maybe this one, enlarge that one. During the pilgrimage, millions of Muslims from around the world come to this courtyard in this mosque. And in the center is this very strange building called the Kaaba. And inserted in, I think, the southeast corner. I didn't check my notes for that. We don't see it here. It's probably over to the left there, around there where they're standing. Is a meteorite about the size of a football, sort of blackish in color. And it was inserted into the wall when they built the Kaaba, probably in the late 600s, early 700s. However, that meteor had been there in the area for who knows how many thousands of years. And the pagan Arabs, before they converted, worshiped this stone at this spot. So, and there are many other famous meteorites around the world. You'd be surprised. So might be a fun thing to do.
I think.
All
Oh,
right.
here it is. Like shown in the.
Oh, there's a picture of it. Yeah, okay. That's what it was. Whoops.
Oh, sorry.
Okay, so there was a picture of it there stuck in the one corner.
Well, maybe.
There we go.
Oh,
Okay. It's probably encased in silver and then embedded into the wall. Okay, to move on, I was thinking, I looked at, do we have the star chart for April still? Can we get to that, or is that,
Oh.
and Melanie is going to put up whatever you need for the star chart for May, because we are almost to May.
Do you want the star chart for May?
No, April's fine. That's what I worked with. While she's working at, I thought I'd point out 4 bright stars that are in the evening sky around 10 p.m. And you might want to take a look at them, even though I think it's going to be pretty cloudy for us this week. That makes it a little harder than the black and white, but oh, there we go. Now, can we, we don't have to enlarge it, but you want to use your cursor? Whoops, where
Yep.
did it go?
Hold on, I gotta share it again.
This is just magic. Who needs astrology when you have a computer?
Okay.
Okay, so let me point out, around 10 o'clock at night, there are going to be 4 bright stars. The first one, let's go look to the west. You want to point right there, Procyon. The bright star that's lingering above the western horizon at around 10 in the evening is part of that winter triangle. Whoops. That's okay. There we go. Part of that winter, Sirius was down here out of sight now, and Betelgeuse is over here out of sight. Can't see them. They've already set at 10 o'clock at night. But Procyon is the brightest star there in the west. Then let's back up.
Let me make it smaller here. Sorry about that.
That's okay. We're having fun. All righty. A new star is Spica. I'm going to point to Spica. I think it's a magnitude 1, and it's in a fairly empty, shall we say, part of the sky. In other words, there are not a lot of other bright stars around it. So if you, at 10 o'clock, you look out to the south and a little bit to the left, it's not right in front of you yet, there will be Spica, about halfway up towards the top of the sky, 40 degrees. Straight overhead, I can't bend my neck anymore, but you guys probably can, is Arcturus. one of the, I think the second brightest star in our northern hemisphere. And take a look, it's part of Boots, looks like a kite, doesn't it? So that's another asterism, a pattern in the sky. And then the third star, no, the fourth star, go back to Spica. Make a curved line through Leo over to Procyon. And there you have Regulus, who has moved since winter towards the west. So now it's more to you towards the west as you look south. The question mark or sickle asterism is still quite apparent. An asterism, a pattern, part of a constellation, Leo. And Regulus is a pretty bright star also. So you might want to get out there on a clear night with your binoculars. Excuse me a minute. And see if you can see those four. Get you. Oh gosh. Goodness gracious. Get out your paper and pencils, and if I can quit coughing, I'll give you your assignments. Oops. All righty. The next 3 times, we're going to cover the moon. So everybody next time, one, the moon was full 2 nights ago. So as soon as, if there's a clear night still tonight, it looks like it's going to be pretty cloudy this week. Get out there and take a look with your binoculars at the moon. Number 2, rummage around in your memory. When can you remember a most beautiful vision of the moon? Doesn't have to be a full moon, it could be. When did the moon strike you as most beautiful? And now, assignments. Brock, are you still there?
Yes.
Yes.
Ready?
Yes.
How old is the moon?
That's the question.
Oh,
Megan, how
Yes.
far away is the moon from us?
Okay.
And by the way, Megan, thank you for taking the guys out to see the conjunction in December. It was cloudy here for 3 nights in a row, so we didn't get
Oh,
to see it at the moment. So
it
thanks
was
for that.
fun. Of course.
They drove up into the mountains outside of San Diego so they could see it. Okay, Rima, well, you write down for Rima. She has to tell me the diameter of the moon. Okay, is Jerry there, Mary Lou, or are you taking down his assignment?
No, but I'll take down his assignment. He
All
hasn't
righty.
practiced for me.
I want him to find out what is the color of the sky if you were standing on the moon. And Mary Lou,
Now, wait a minute, I gotta write this down.
color of the sky. And you're on the moon.
Yeah,
You're on the moon with him.
okay.
What is the sound of the wind? Now, you all remember, I don't remember if the West Coast was here, and if they aren't, you guys should find it on the computer and listen to it. They landed something on Mars a month or 2 or 3 ago, and we listened to the sound of the wind on Mars, and it was so amazing. So if you haven't listened to that, if you didn't catch it on the news or whatever, go find it because it'll make your hair stand up on end. Okay, Jordan, a history one for you. You ready?
Okay. Yeah.
If you look at what we call the backside of the moon, almost all the names, the craters, are in Russian. Why is that?
Okay.
Okay. Bob, you here? Bob?
Yeah, go ahead.
Okay. Why do we always see the same side of the moon? We on Earth.
Okay.
Okay. Debbie, did you sign in today or you're not here?
No, she's not.
Well, I'm going to call her up she's not gonna wiggle out, because she's busy, maybe as an EMT. She's running off somewhere with the ambulance. I'm gonna ask Debbie to tell us the origin of the moon. How do we get our moon? Is Anne listening, Bob? Or you can give her a question?
She's listening.
All righty. And if we were to transport you to the moon, or somebody, it doesn't have to be you, what would they weigh? And I'm
Okay.
sure, okay, the next week, we're basically going to be talking about the generalities of the moon. Oh, is there somebody else that was, Drew, you didn't get a
Yeah, I'll
question,
take
did
the
you?
question. Yeah.
What's a blue moon? Okay. I'm gonna remind me to write that down so I don't forget next time.
Okay.
All righty. And then the following 2 weeks, it's gonna be basically on the phases of the moon and the tides. And the last time, the third week, will be eclipses of basically of the moon, but also the flip side of that is the moon causes the solar eclipses. So there was a lot to talk about the moon, and I decided to break it up into those 3 sections. And I've been doing research, and I keep getting more and more and more stuff. So anyway, anybody have questions before we all sign off?
So when is the next session? 'Cause-
In 2 weeks. So that would be,
Which is the 11th of May?
yes, that sounds right.
Okay, and then the next one is the 25th,
Yes, that sounds right.
Yes, and then we're into June.
and then we're into June.
And what I'm hoping to do, Sandy didn't sign in today. They're in Albany, and she sometimes gets busy. But they have a place about 7 miles out of Alfred, up the back road to Scioto from Five Corners, and a very nice place with a wonderful porch and patio that face basically north, slightly northeast. Beautiful fields, clear skies. And so when they're here in June, I want to make an arrangement instead of maybe of our Tuesday afternoon meeting out there in the evening at 9 o'clock, because by then it's the summer solstice and it doesn't get dark until 10. But we can sit on the porch in the patio and we can study the circumpolar stars, all those stars that rotate around Polaris to the North Star. So we'll think about that. You can just sleep late in whatever morning. We have to pick a night when it's clear and sleep in late or take a nap so that we can go out there at 9 and it'll get dark enough to really see by 10, and so it'll be like a 9 to an 11 kind of a thing. So no questions. We'll wrap it up then. Bob, you have anything?
No. No questions.
Okay, bye guys.
Bye-bye.
Bye.
Wait.
I have a question.
All right.
What's your favorite constellation?
Oh, can I have 2?
Yes.
All right. In the wintertime, I'd guess I have to say Orion. And in the summertime, I love Scorpio or Scorpius.
Okay.
Uh-huh. And
Thank
when
you.
summer comes, we have a lot of fun things to, there's a great globular cluster in Scorpio and a couple of open clusters. And it's one of the few constellations that actually looks like a scorpion.
Oh, yeah. That actually looks like it's.
Yeah. And then, of course, there's a story about him biting Orion, the hunter, right? I think. Yeah. Okay. Bye.
Thank you.
Bye.
Bye.
Thank you.
Bye.
So I guess Laura.